The Tablo system is a next-generation hemodialysis device designed for both clinical and home environments. It integrates water purification, dialysate generation, and automated cleaning into a single mobile unit. Manufactured by Outset Medical in San Jose, California, the Tablo system was FDA-Cleared in 2020 and CE marked for international use. It functions as an all-in-one hemodialysis system with built-in water purification and automated dialysate production. Dialysis removes uremic toxins, regulates electrolytes, and restores fluid and pH balance. These outcomes are achieved through three primary mechanisms. Diffusion governs how solutes move across the membrane based on concentration gradients. Filtration determines how fluid is removed by measuring the pressure difference across the membrane. Convection explains how larger molecules are carried along with fluid movement. All of these processes occur across a semi-permeable membrane that separates blood from dialysate, allowing selective exchange while retaining essential components. The dialyzer membrane is made of polyethersulfone and ranges in thickness from 20 to 50 micrometers. Solute transport occurs through both diffusion and fluid-driven movement. The membrane has distinct layers with varying diffusivity, allowing controlled passage of substances while maintaining structural integrity. Solute flux is calculated based on how easily a substance moves through the membrane and its concentration. Permeability is determined by how quickly a substance passes through a given thickness. Hemodialysis removes small toxins like urea and creatinine, excess water, and some medium-sized molecules. Proteins and blood cells are retained due to their larger size. Membrane pores range from 3 to 30 nanometers, with pore formation controlled through a polymer phase inversion process. Albumin, which measures approximately 4 nanometers, is too large to pass through the membrane. The Tablo system maintains optimal dialysis performance by regulating blood and dialysate flow rates. Blood flow ranges from 100 to 400 milliliters per minute, while dialysate flow reaches up to 300 milliliters per minute. Ultrafiltration removes up to 2 liters of fluid per hour, calculated based on pressure differences across the membrane. On-demand dialysate generation ensures proper sodium and solute balance. Pressure sensors continuously monitor transmembrane pressure to stabilize fluid removal. These automated controls form a closed-loop system that adjusts in real time to maintain safe and effective treatment. The Tablo system includes 4 subsystems. The blood circuit features arterial and venous lines, a peristaltic pump, and safety sensors. The dialysate circuit includes inline water purification and a mixing chamber. The ultrafiltration module monitors fluid removal. Safety systems detect air, leaks, temperature shifts, and conductivity changes. A one-touch operation and a guided touchscreen interface reduce training time by 65%. Step-by-step prompts minimize operator error. Remote monitoring allows live treatment tracking and data logging. The system is FDA-cleared for both acute and home dialysis. Quiet pumps and adaptive flow control improve patient comfort. The cleaning cycle includes rinse back to flush residual fluid, heat disinfection above 80 degrees Celsius, and sensor verification before reuse. Manual maintenance risks are minimized by automated sterilization, ensuring safe and sterile fluid pathways for the next patient. Tablo includes built-in water purification, automated setup, and a smart touchscreen interface. It supports cloud-based data access and offline operation. Treatment sessions last 30 to 60 minutes, with cleaning completed in 5 minutes. In contrast, the Fresenius 2008K requires external water, manual setup, and has longer treatment and cleaning times. Limitations include reduced validation in extreme environments and lower blood flow capacity for high-volume treatments. Internal pump wear requires scheduled servicing. The system depends on stable electricity and water supply, and connectivity features rely on Wi-Fi stability. Spare parts may be limited in remote regions.